Hello, discrete math fans. Now we'll talk about telescoping sums, which is a topic that you saw in Calculus 2. Let's look at this algebraic trick. Take these two things, 1 over k minus 1 over k plus 1, subtract them. Now, that's a pretty easy thing to do. You make a common denominator, and then everything cancels out, and you get 1 over k times k plus 1. If you'll remember, from Calculus 2, the step of going backwards is what's called a partial fractions decomposition. So now, as an example, let's use this identity to find a simple expression for the sum where k goes from 1 to n of 1 over k times k plus 1. All right, so we start with this sum. K goes from 1 to n of 1 over k times k plus 1. And we use that decomposition that we just showed. Essentially, it's the partial fractions decomposition. But even if you didn't know that, that algebraic step that we went through before we started shows you why this is true. So that's just algebra, nothing fancy. And now we'll write out the terms. So when k equals 1, we'll get this guy. When k equals 2, we get this guy. K equals 3. And so on, all the way up to k equals n here. Notice here's k equals n minus 1. All right, now we're going to do a little bit of canceling, because a lot of things cancel out, like the 1/2, the 1/3. The 1/4 cancels with, or the minus 1/4 cancels with something you don't see. Let's look at the very end. The minus 1 over n and the 1 over n cancel. And the 1 over n minus 1 cancels with something that you don't see before it. So let's see what we end up with. Notice that the only thing that's left after all the cancellation is the 1 and the negative 1 over n plus 1. And so in our final result, we end up with 1 minus 1 over n plus 1. So a little bit of work actually gives us a nice expression that doesn't have any sums involved. Okay, that's all for now.